So for B, we're going to solve this system using matrices as well, and it says row operations. So first off, I'm going to write this as an augmented matrix, and I'm going to need all the room I could get here. So this is going to be negative 1, 1, 1, and negative 1, and that's going to be the first row here. And then for the second row, we're going to get negative 1, 2, negative 3, negative 4. And then for the third row, we're going to get 3, negative 2, negative 7, and 0 here. And that's going to be our augmented matrix. Now what we're going to do here is we're going to do the same thing we did for the first one there, and we're going to try to get 1s on all the diagonals and 0s everywhere else. All right, so the first thing we're going to do is we're going to make this first entry a positive 1, because it has to be a 1 there, not a negative 1. It has to be 1 on the diagonals. So that's what we're going to do first. So we're going to take this first row and multiply it by negative 1, and then we're going to replace it. So that's going to be a positive 1, because a negative 1 times negative 1 is positive 1, and that's why I used a negative 1 there. And a negative 1 times a 1 is going to be a negative 1. And then a negative 1 times 1 is going to be negative 1. And then a negative 1 times a negative 1 is positive 1. So there we go. That's our first row. And then the second and third row we didn't do anything to, so I'm just going to rewrite those and then work on our next step. Oops, that's a 3. Negative 2, negative 7, and 0 there. So there's our other two rows there. Now we're going to get rid of all of the zeros below the first entry 1 there. So we're going to make these 2 zeros. And what we're going to do is we have to use the first row for each of these entries to make them zeros. So what I mean by that is we're thinking of this idea of opposites because we're going to add them. So if I take just R1 and I add it to R2, what we'll see here is that will end up giving me 0. So I'll show you what that looks like below here. So I'm going to get a 1, negative 1, negative 1, 1. And that's going to be my first row here. And I'm going to add it to row 2, which is negative 1, 2, negative 3, negative 4. And when I add those together, I'm going to get a 0 here. And this is going to be a positive 1. This is going to be a negative 4 because I'm adding those two together. And then this is going to give me negative 3. So in adding all those, I end up with this new row for number 2. So what I would do then is I would keep the same first row because I didn't do anything different. And then for the second row, I'll put in that new row that we just made from 1 and 2. And that's going to be 0, negative 4, negative 3. Now what I'm going to do here is I'm going to do the third row as well. Now to deal with the third row, if I'm going to make this 1 here opposite to this 3 here, I'm going to times R1 by negative 3. And then I'm going to add it to R3. So what that means then is I'm just going to take my first row and times it by negative 3. So then when I take this row here and times it by negative 3, I'm going to get a negative 3. And then when I take this negative 3 times negative 1, that's going to give me a positive 3. And then I do the same thing for the next one. I'm also going to get a positive 3. And then for the last one here, it's going to be 1 times negative 3, and that's going to be negative 3. And then what I'm going to do is just take the third row, and I'm going to add it to that. So it's going to be 3, negative 2. And now this is the third row here, just in case you were wondering. Negative 7 and 0. And then I'm just going to add that row to that row. And then for the first entry is negative 3, positive 3. That's going to give me 0. And then 3, negative 2 is going to give me a positive 1. And then negative 4, and then negative 3. So that's what I'm going to put in place of the third row. So that's going to be 0, 1, negative 4, negative 3. Now, if you notice in our step there, I ended up getting zeros below the first entry 1. Now, if you notice for my next step then, my second row, second entry is already a 1. Now remember what we're trying to accomplish here. We're trying to get 1 on all the diagonals here. So I already have a 1 here. So now what I need to do is make zeros above that entry and below that entry. Because remember, there only has to be 1 on the diagonals and 0 everywhere else. So this negative 1 is going to have to be a 0, and that 1 below it is going to also have to be a 0. So now what I'm going to do is I'm just going to go below here. And I want to rewrite it, but I'm not going to. I'm going to try to work with it from over there. So now I'm going to take my R2, and I'm going to start multiplying that by things to make it opposites to, let's say, the row above it first, to get rid of that negative 1 there. And if I notice here, those are already opposites, and that's already a positive 1 for that second entry, second row, second entry. Okay, so anyway, so what I'm going to do here is I'm going to take, and I'm going to replace that first row by R2 plus R1. And then I'm going to add those together. And I'll show you what that looks like below here. Let me try to write that a little straighter. Okay, so that's going to be 0, 1, negative 4, negative 3, and then my row 1 here, and that's just this row right here, and it's going to be 1, negative 1, negative 1, 1, and I'm going to take and add those together. Now what I'm going to get here is 1, 0, negative 5, and negative 2. So that's going to be my first row, because that's what I'm replacing now. So that's going to be 1, 0, negative 5, negative 2. So now I'm going to look at my second row, and that is just what it is. That doesn't change. The rows above it and below it are going to change, but that not that row. So then for the third row, if you look at what we have to get here, we have to get rid of the 1 below the second entry, second row. So this 1 has to go. So that means I'm going to have to multiply the second row by negative 1, because negative 1 times 1 is going to be negative 1, and when I add those, I'm going to get 0. So this R3 then, I'm going to take negative R2 plus R3. Now you notice the rows I'm swapping out, I'm always including that row in the addition process here. So when I was replacing row 1, I'm using row 1 in that addition there. And then for the previous one, when I swap the second row and the third row, notice that's an R3 for the third row, that's an R2 for the second row. So that's essential here when we're dealing with these. So now I'm replacing my row 3, so that's why we see this R3 here. Okay, so anyways, so negative R2, so here's my R2. So that's going to be 0, negative 1, positive 4, positive 3, because it's like I'm timesing each of these by a negative 1. Okay, and then for my second, or my third row, that's just going to be 0, 1, negative 4, negative 3. And when I add those together, I'm going to get 0, 0, 0, and 0. So that's going to give me this row of zeros here. Now, hopefully from this process, you realize that we are done with this problem. And the reason why I say that is because this row of zeros I end up with, that's going to be 0x plus 0y plus 0z equals 0. So I'm going to end up with 0 equals 0, which tells me that I have infinite number of solutions, because 0 does equal 0. That's a true statement. And also, notice our process here. So I got 1 on the diagonals, 0'd everything else above and below it. And then I have anything above it, but below it I had 2. And when I hit the middle entry here, I had 1 above and 1 below, and I made those both zeros. Now, if I had to continue the process, let's say I would have to make this a 1 next, and then I would have to make zeros above it. And then once I do that, that's my final answer. But this one turned out to be infinite number solutions, so I ended up with a row zeros right away. Now, if this turned out to be a no solution, this would have to be a number other than 0 here in the far right bottom corner here. So that's how that works. And that's like 0 equals some number other than 0. So there's our answer.